in this video, we're actually going to put this into practice. We're going to find our line of best fit and correlation coefficient using DESMOS. So this problem says the table below shows the durations x in minutes of several eruptions of the geyser Old Faithful and the time y in minutes until the next eruption. And when we're doing our line of best fit, we're going to go ahead and round our slope and our y-intercept to the nearest whole number. So I'm going to go ahead and follow these directions. So I'm going to first enter the table by clicking the plus button. And so I'm going to go ahead and enter in all my x values first. So 2, and then I'm going to enter in my y values. Okay, then the next step says to click on the next line and type in y1 mx1 plus b. So the important thing to not forget is you need that one subscript for both your y and your x, because that lets DESMOS know that you're using these two data points. So I'm going to click here, I'm going to y, and then on your keyboard in the top left corner, if you hit shift, and then you should see that button there. Or if you can't see it, if you click on this keyboard and click on ABC, you'll see it right there. And then I already made the mistake, but for my y, I need to make sure I put that subscript 1. So again, you could hit shift dash on your keyboard and you can get the 1. Or if you look at this keyboard down here, you'll see a subscript option to the left of that exclamation point. And you can put the 1. And then I have plus b. And so I see when that happens, I got all of these results right here. And so back to our directions, it says that m is the slope of the line and b is my y-intercept. So I have my slope is 11.99, but I'm going to go ahead and round that to 12. My y-intercept is b, which is, I'm going to go ahead and round to 35. And then my correlation coefficient is the r value and not r squared. So I'm going to look at that r value here, not r squared. But we can actually see from our line best fit, we can see it goes through all of those points evenly. Okay, so my line of best fit, we found that the m value was 12. And the b value is 35. So if recall, my slope-intercept form is y equals mx plus b, so that means that my line of best fit here is y is equal to 12x plus b. And then my correlation coefficient, remember, is the r, not r squared, and so that is going to be 0.9. I'm going to go ahead and round that to 0.979. Okay, so now we're going to go ahead and analyze all this. So part A says, is the correlation of the data positive, negative, or no correlation? Well, we learned about that first video. The closer it is to 1, then it's positive. And this r value is 0.979, so it's really close to 1. So I'm going to say that this is a strong positive correlation. It is very close to positive 1. And we can see that in our graph. This line almost goes through all of the data points evenly. Okay, now let's do some interpreting. So now it says interpret the slope and y-intercept of the line of best fit. So my slope here is 12. And I know slope is rise over run, or in other words, it's my change in y over my change in x. So I can put a 1 over here below it. And this is my change in y over my change in x. Well, what does y represent? Y represents the time in minutes until the next eruption, where x represents the duration of the eruption. So if I am interpreting this, I can say that this means the time until the next eruption increases by 12 minutes for each minute the duration increases. So remember the 12 minutes for each minute, or the eruption increases by 12 minutes for each minute the duration increases. And then my slope, or my y-intercept, was 35. So that's my y value, and so that is my time until the next eruption. But if you remember for my y-intercept, that means that my x value is 0. So this is really the same thing as the point 035. Well, I can't have a duration of 0 minutes for an eruption, so this is going to have no meaning. So no meaning. Since the duration can't be 0 minutes. Okay, so now for this next part it says approximate the time until the next eruption if the duration of the eruption was 2.7 minutes. So I want to approximate the time, so that is my y value. But I'm told the duration of the eruption was 2.7 minutes. And so the duration is my x. So I know that x is equal to 2.7. So I want to find my y value. So that's where we're going to use our line of best fit. That should have said 35. So my line of best fit, y equals 12x plus 35. But I know that the duration is 2.7, so I'm going to go ahead and plug in 2.7 in for x. And so when I do that, 12 times 2.7, I get 32.4. So y is equal to 67.4 minutes. Okay, go ahead and pause the video. I want you to try and do that last one on your own. Okay, so for this last one, you should have gotten 3.33 minutes. So this time we wanted to approximate the duration of the eruption, so that was my x. And we're told that the next eruption occurred 75 minutes later, so that is my y. So I plugged in 75 for y, and when I solved for x, that meant that that duration lasted 3.33 minutes. Okay, that's it for today. If you want to look at some more examples, those are linked below. If you need some extra help, I am always available through inbox. Otherwise, I hope you all have a great rest of your day.